Hello dear students, so today we will be starting with hydrocarbons, alkynes. This is the third kind of hydrocarbon where you have triple bond between C and C carbon atoms. Let's see the definition of alkynes. It is the aliphatic hydrocarbons. Aliphatic means straight chain, which we have already discussed in the first video, where I've explained about the differences between alkanes, alkenes and alkynes. So they are the aliphatic hydrocarbons that contains triple bond between two carbon atoms, and this bond is known as acetylenic bond. They are unsaturated hydrocarbons, as you know that alkenes and alkynes both are unsaturated, whereas alkanes are saturated, and why they are so I have explained so many times in my previous videos. Each carbon is not satisfied with the 4 hydrogen, that is why it is unsaturated. And the general formula for this chain is, this series is CnH2n minus 2. That means first you have to multiply the carbon numbers to 2 and then you have to deduct 2 from that. For example, if you have C2, then it will be C2H4 and then from that 2 will be minus. And the source of alkynes is basically natural gas and petroleum. This is the homologous series of alkynes. Here you can see C2H2. So this is the general formula. So like C is 3, then it will be H will be 6, that is double of carbon numbers, and then minus 2. So it will bring down H to 4. So this is how you will calculate the molecular formula using general formula if you know the number of carbon atoms. And this is the condensed formula. You can see a triple bond here between any carbon and carbon atom. This is the structural formula, and then name, trivial name is acetylene of ethyne, alylene of propyne, crotonylene of butane, and propyl acetylene of pentyne. So you know what is ethyne, propyne, butane, pentyne and how do we name it, but the trivial name or common name should be learnt. Then we see isomerism in alkynes. So first we'll check about the position, because they also show both isomerism, that is position isomerism as well as chain isomerism. So let's see the example of position isomerism here. The position of this triple bond is on 1 number, so this is but1-ine, and this is on 1 and 2 numbers, so this is but2-ine. It can be written as butane also, because 1 we don't mention generally. If 1 is not mentioned, that means the triple bond is on 1 carbon only, and otherwise we have to mention if it is on 2, 3 or 4. So this is position isomerism, where the position of triple bond is different, although the molecular formula remains the same. Then comes the next, that is chain isomerism. Here you can see this is the straight chain. This also we have seen in the last slide that position has changed. So 5 carbon, that means pent on 1 triple bond, so pent 1-ine, on 2 triple bond, then pent 2-ine. But suppose this 1 carbon goes down like this in a branch chain, then it will be this will be methyl group here. 1 will be this carbon, 2 will be this, 3 will be this, and 4 will be this. So the name will be, first of all we'll see the position of this alkyl group. So it is on number 3. So 3 methyl and then but1-ine, because on 1 it is triple bond. Now here you have to mention this one, the triple bond is on number 1. So 3 methyl but1-ine is the name. Otherwise the molecular formula remains the same, that is 5 carbons only are present. So the first member of this series is ethyne, which is also known as acetylene, and this is present in traces in coal gas. And what is coal gas? Mixture of hydrogen, methane and carbon monoxide, which is obtained by the destructive distillation of coal. Destructive distillation means heating in the absence of air. It is also produced during cracking of alkanes from various fractions of petroleum. Cracking, what is cracking? It is the process in which the heavy molecules, the bigger molecules of hydrocarbon, break down into smaller or lighter molecules by means of heat or pressure or sometimes catalyst. And then it is obtained by the decomposition of complex organic compound. Compounds are decomposed, are broken down, then these are ethyne is obtained. So the structure of ethyne, it is important because it is usually asked in the exams. What is the structure of ethyne? So each carbon atom is attached to one hydrogen atom by single covalent bond. So in between carbon-carbon it's triple covalent bond. Okay, but here between one carbon and hydrogen, it is single covalent bond. As you can see here, the shape of ethyne molecule is linear. This is the electron dot formula, or you can say this is the structural formula of ethyne. So laboratory preparation of ethyne is not in your syllabus for this year, so I am directly switching over to the physical properties, but later on I will be making a video on the laboratory preparations also. So subscribe the channel so that once it is uploaded, you get to know. Now coming up to the physical properties, ethyne is a colorless gas with an ether-like sweet odor. Ether, as you know, it is the functional group which we have already studied in the first video. So it has a sweet odor. So you can identify ethyne by the sweet odor, and the sweet odor is only once it is pure. So although laboratory preparation is not there in the syllabus, but I am using the reaction which is actually the laboratory preparation of acetylene, and because I want to tell you this odor from where this garlic odor is coming, so we will take this reaction. This is laboratory preparation of acetylene or ethyne. So we will take calcium carbide and we will make it react with water, and this will give you calcium hydroxide and formation of ethyne will happen. Okay, now as you know that this calcium carbide is not pure, it contains some impurities of calcium sulfide and calcium phosphide. So calcium sulfide is present and calcium phosphide is present. Now this calcium sulfide, later on after the reaction, there will be the formation of hydrogen sulfide and phosphine. So phosphine formula is pH 3. Okay, now this which when it is prepared with this, that is calcium carbide, it will have a odor of garlic. Why? Because of the formation of phosphine and hydrogen sulfide as impurities when it is prepared in lab by calcium carbide. Otherwise, when it is pure, it will have a odor of ether. So it has garlic odor due to the presence of traces of phosphine and hydrogen sulfide. And from where this phosphine and hydrogen sulfide have come? From the impurities in calcium carbide, which was used to prepare ethyne in the laboratory. Negligibly soluble in water but highly soluble in organic solvent like acetone and alcohol. It is lighter than air. So vapor density of ethyne is 13 and vapor density of air is somewhere around 14.4. So it is lighter than air and it liquefies at minus 84 degrees Celsius and boiling point is minus 75 degrees Celsius. Okay, now let's start with chemical properties. So first we will see the oxidation of ethyne, that is combustion reaction. So as I told you in the last video also, that combustion reactions are really important. So you have to learn all the combustion reaction. But before studying this combustion reaction, I would tell you that ethyne actually has a greater proportion of carbon content than alkanes and alkenes, and that is why it does not oxidize completely and burns with a sooty flame. And to understand this, you have to, I'm giving you one example so that you understand this line better. See, if I take the example of C6 and H14, this is alkane, okay, this is alkane, then C6H12 is alkene, and C6H10 is alkyne. Okay, I'm taking the example of hex, that is 6 carbon. Now as you can see, in alkanes, the number of hydrogen atom than the carbon is 2 more than the double, and hydrogen is a clean fuel, so it will burn with very bright blue non-sooty flame because hydrogen is a clean fuel, and the number of carbon atom is quite less as compared to hydrogen here. Again in alkene also you can see it's double. If you have 6 carbon, you have 12 hydrogen, so it is double. The number of hydrogen atom is double than the carbon, so it also burns with quite good flame. But in alkyne, as you see, the number of carbon and hydrogen, the difference is very less. It is double and then minus 2. So this means that the proportion of hydrogen as compared to carbon is less. So this is one reason why alkyne burns with the sooty flame. So the content of carbon is more in alkyne as compared to alkene and alkane. So that is why we say that ethyne contains a greater proportion of carbon content than alkanes and alkenes, and all the carbon particles do not get oxidized properly. और जब अच्छे से ऑक्सीडाइज नहीं करेंगे तो अनबर्न कार्बन रह जाएगा, तो सूटी फ्लेम होगी. ऑल्दो अगर हम इस इथाइन को हम एक्सेस ऑफ एयर में बर्न करेंगे तो ब्रिलियंट वाइट फ्लेम के साथ वो बर्न करेगा, और साथ में क्या प्रोड्यूस करेगा? इट विल प्रोड्यूस कार्बन डाइऑक्साइड एंड water vapor. Large amount of heat is given. So ethyne, when this is ethyne, it is burnt in plenty of oxygen, large amount of air, excess of air, then it produces carbon dioxide and water vapor and large amount of heat. So this is the combustion reaction, or you can say oxidation of ethyne. Okay, so another chemical properties of alkynes are addition reaction. And why this addition will happen? This addition reaction will happen because triple bond can be broken down easily, and this hydrogen will add up to ethyne to form another unsaturated hydrocarbon, that is alkene. And again this alkene, again hydrogen will be added to form a saturated hydrocarbon, that is alkane. तो पहले अल्काइन से अल्कीन बनेगा और फिर अल्कीन से अल्केन बनेगा. तो दो स्टेजेस में ये रिएक्शंस होंगे. ओके, तो एक अनसैचुरेटेड से अनसैचुरेटेड और फिर अनसैचुरेटेड से सैचुरेटेड बनेगा. तो यहाँ पे पहला जो रिएक्शन हमारा आ रहा है वो है हमारा एडिशन ऑफ हाइड्रोजन, और दिस इज ऑल्सो नोन एज कैटालिटिक हाइड्रोजनेशन. एंड व्हाई इट इज नोन एज कैटालिटिक हाइड्रोजनेशन? बिकॉज इट हैपन्स इन द प्रेजेंस ऑफ निकल और platinum or palladium as a catalyst. तो इस catalyst के presence में first ethyne will take up 2 hydrogen atoms and change to ethene, and then with another addition of hydrogen it will change to ethane. Let's see the mechanism. So C is there, then triple bond is there between C, then H is there, then H is there. A hydrogen will be added here, so plus hydrogen. So what will be formed? Again you will see this catalyst will break this bond, and the structure will be, after breaking up of this bond, the structure will be C double bond C, H and H, and this place will be empty. So this hydrogen, one hydrogen will go here, another hydrogen will go here, and what is this compound formed? So the compound form will be C2H4. Now again this C2H4, again this, so we will draw the structure of C2H4, C double bond C, H here, H here, H here and H here. Now again what will happen? You will put the catalyst, so this bond will break and the structure will become like this. So two places will be there. So again this hydrogen, one hydrogen here and another hydrogen here. So now the compound which is formed is this. This is C2H6. And what is C2H6? It is alkane, that is it is ethane. So this is the mechanism of the reaction. So you can see here ethyne is converted to ethene, and then ethene is converted to ethane. So this is the second stage, the whole reaction. So this was the addition reaction, or it is also known as hydrogenation. So we will see the addition reaction of halogen. This ethyne will be chlorine will be added to ethyne, and from where do we get this chlorine? We will get it from carbon tetrachloride. That means you have to make the solution of ethyne and carbon tetrachloride. So because ethyne is dissolving in carbon tetrachloride, then this reaction will happen. So you can see here, this chlorine I am getting from carbon tetrachloride, and again this breaking of this bond will happen, and you will get two places empty here when this bond will break and open up. So इसको हटा देंगे यहाँ से. अब ये बन गया, और अब यहाँ से एक क्लोरीन यहाँ पे and one chlorine will come here. So what is the structure now? It will be C2H2Cl2. So this is the formation of 1,2-dichloroethene. कैसे नेम करेंगे? 1 2, 1 पे भी क्लोरीन, 2 पे भी क्लोरीन, तो 1,2 डाइक्लोरो, 2 क्लोरीन है, डाइक्लोरो, और 2 कार्बन है तो एथ, और एक डबल बॉन्ड है, इथीन. सो दिस इज द नेम ऑफ दिस कंपाउंड 1,2-dichloroethene. ethene. Further what will happen? Now again this reaction after this formation of this compound, ये बन गया compound हमारा. After the formation of this compound बना है हमारा ये वाला compound, इसका reaction मैं फिर से chlorine के साथ करा रही हूँ. Then what will happen? Again same. Now this bond will break and it will create positions here. और ये वाला एक chlorine इधर और दूसरा chlorine इधर आ गया. तो let's again see the structure. क्या बन जाएगा हमारा? So now we have this structure. So अब फिर से इसकी नेमिंग करेंगे. So 1 और 2, तो इसका नाम क्या हो जाएगा? 1 पे 2 और 2 पे भी 2, तो हम इस तरह से लिखेंगे इसको 1,1 एंड 2,2. और कितने क्लोरीन हो गए? 1 2 3 4. सो टेट्रा, तो लिखेंगे 1,2,2,2. देन वी विल राइट टेट्रा क्लोरो. ठीक है, टेट्रा क्लोरो हो गए. 2 कार्बन है 1 2, तो एथ रहेगा और सिंगल बॉन्ड है तो इथेन. So 1,1 2,2 tetrachloroethane is the name of this compound. तो you have seen कि सबसे पहले ट्रिपल बॉन्ड था, टूटा डबल बॉन्ड में आया, डबल बॉन्ड से टूट के सिंगल बॉन्ड में आ गया, तो यहाँ पे आके ये रिएक्शन कंप्लीट हो गया आपका. ठीक है, तो ये तो हो गया. दिस वाज रिएक्शन विथ क्लोरीन, दैट इज एडिशन ऑफ हैलोजेंस व्हिच आई हैव एक्सप्लेन्ड. एसिटाइलिन रिएक्ट्स विगरसली विथ क्लोरीन gas in the presence of sunlight. Now this reaction happens in the presence of sunlight. Sunlight की presence में ethyne will react with chlorine to give hydrochloric acid. And because this reaction is very vigorous, so you can see flames also. So addition of halogen. Now here we'll see the reaction of bromine. Now this reaction is actually similar to the addition of bromine in alkenes, where we have studied that bromine is dissolved in carbon tetrachloride and its brown color disappears. So same thing will happen here. When that bromine is when bromine dissolved in carbon tetrachloride is added to ethyne, okay, then what will happen? Its brown color disappears due to the formation of addition product, and dibromomane or tetrabromoethane is formed. And from where this bromine is coming here, यहाँ पे हम ये reaction with कार्बन टेट्राब्रोमाइड के साथ भी ये रिएक्शन हम कर सकते हैं, जहाँ से हमें ब्रोमीन मिलता है. सो अगेन सेम थिंग, पहले सिंगल डबल बॉन्ड में आ जाएगा, इथीन बनेगा, फिर सिंगल बॉन्ड में आके इथेन बन जाएगा. जैसे सेम अभी हमने पीछे जो मैकेनिज्म देखा है, द सेम मैकेनिज्म विल बी फॉलोड हियर ऑल्सो. रिएक्शन विथ आयोडीन. सो आयोडीन रिएक्ट स्लोली विथ इथाइन इन द प्रेजेंस ऑफ alcohol to form a diiodo derivative. Okay, so this is the addition reaction of chlorine, bromine and iodine. These are very important reactions and you have to learn all the addition reactions properly so that you can write the reactions. You will just break this bond and you will make one bond free here and you will add this I here. So you will get this compound as 1,2-diiodoethene. Then uses of ethyne actually is not in the syllabus for this year, but I will tell you some uses before starting the chemical test to distinguish between alkanes, alkenes and alkynes. So uses are, they are used for oxyacetylene welding at very high temperature, for artificial ripening and preservation of fruit. So if you want to artificially ripe the fruit, you will use ethyne. And also for the manufacture of synthetic products like polymers, rubbers, oxalic acids, etc. And also for the manufacture of organic compounds like acetaldehyde, acetic acid, plastic and rubber, this ethyne is used. Okay, now this is very important, that is chemical test to distinguish between alkanes, alkenes and alkynes. So these are some tests which you have to remember, which you have to learn. On adding a few drops of bromine solution in carbon tetrachloride to the hydrocarbon, no changes observed in alkanes because there is no breaking of bond. But the reddish brown color of bromine gets decolorized. Why it is so? Because the breaking of bonds will be happening. Unsaturated will be turning to saturated. And similarly here also the same. तो ब्रोमीन को हम यूज़ करते हैं कार्बन टेट्राक्लोराइड सॉल्यूशन में टेस्ट करने के लिए कि आपका रिएक्शन हुआ है, ब्रेकिंग ऑफ बॉन्ड, डबल बॉन्ड से ट्रिपल बॉन्ड से डबल बॉन्ड और डबल बॉन्ड से सिंगल बॉन्ड बना है या नहीं बना. तो रेडिश ब्राउन कलर विल गेट डीकलराइज, वेर एज इन अल्केन्स यू विल नॉट सी एनी चेंज. जनरली जो टेस्ट है ये हम इसलिए करते हैं सो दैट वी कैन come to know whether the given organic compound is saturated or unsaturated, that is the presence of double bond or triple bond. So Bayer's reagent, that is this alkaline potassium permanganate, the purple color will fade in unsaturated, and in saturated it will remain the same, that is no changes observed. Here you can see oxalic acid is formed after if we take ethyne and we add this Bayer's reagent, that is alkaline potassium permanganate, formation of oxalic acid will happen. And let's see the formation of this organism. We'll understand so that you can learn the structure of oxalic acid also. आपने यहाँ पे देखा triple bond C and H था, and then this reaction will happen with 4O. 4O will be added, ठीक है, तब ये रिएक्शन होगा. और ये 4O कहाँ से आएंगे? ये हमारे आएंगे ऑक्सीडाइजिंग एजेंट से. सो दिस ऑक्सीडाइजिंग एजेंट मैंने आपको पहले ही बताया कि ये जब O है ये, तो ये जब भी H के साथ इसको जगह मिलेगी, इट विल कम एंड accommodate here. 1O and 1O will accommodate here, ठीक है. फिर दो बचे O, तो ये दो में से एक O यहाँ आ जाएगा डबल बॉन्ड के साथ, और दूसरा O यहाँ आ जाएगा डबल बॉन्ड के साथ, और ये ब्रेक हो जाएगा. So this is the mechanism. So let's see the structure कि सारे O accommodate कैसे होगा इसमें. तो जो स्ट्रक्चर बनेगा वो आपका इस तरह से बन जाएगा. C सिंगल बॉन्ड C के साथ OH एक तरफ, OH एक तरफ, एंड डबल बॉन्ड O एक तरफ और डबल बॉन्ड एक. तो ये फॉर्मेशन हो गई आपकी ऑक्सैलिक एसिड की. ओके, सो दिस इज द फॉर्मेशन ऑफ ऑक्सैलिक एसिड बाय एडिंग ऑक्सीजन टू इथाइन. तो इथाइन में जब ऑक्सीजन ऐड होगी 4O, तो ऑक्सैलिक एसिड बनेगा. और ऑक्सैलिक एसिड का जो स्ट्रक्चरल फार्मूला है, वो जो मॉलिक्यूलर फार्मूला है, वो है C2H2O4. सो दिस इज द molecular formula of oxalic acid, and the condensed formula is HOOC, then single bond COOH. So it is the condensed formula, or it is also known as dicarboxylic acid, because there are two carboxylic group here, so it is known as dicarboxylic acid. It is also, you can also write it as COOH, single bond COOH. You can write like this also, and sometimes it is written as this also. Okay, so this is oxalic acid. Now comes the next, that is on adding a few drops of ammoniacal cuprous chloride, that is Felling's solution. Okay, this is known as Felling's solution. No changes observed in both, that is alkanes and alkenes, but change will be observed. So this copper acetylide is formation of red precipitate of copper acetylide. And on adding ammoniacal silver nitrate, which is Tollens reagent, no change, and white precipitate of silver acetylide is formed. So ammoniacal silver nitrate is Tollens reagent. So in higher classes, you will learn how Tollens reagent is used used for detection of aldehyde functional group, or differentiate between ketones and aldehyde. So these you will study in higher classes. So thus we have finished the organic chemistry part of the. If you like them, subscribe.